Math 1314, section IC1, spring 2022, Tyler Junior College, section 1.2, linear equations, video 2, multi-step linear equations. In the previous video, we looked at some basic linear equations where we only had to do one move to get the equation solved, either add to both sides, subtract to both sides, multiply to both sides, or divide both sides. But many linear equations require more than one move. So we're going to take a look at some of those multi-step linear equations and try to figure out the best strategy for solving them. All right, so let's start with a pretty straightforward example. Why don't we solve something like 3x minus 19, and we'll put that equal to, I don't know, how about something like 32? We'll see how that turns out. Well, solving an equation is still goal-oriented. Our goal is to get the x by itself. And the obstacles in our way currently are the 3 multiplied in front of the x and the 19 being subtracted. So we know the moves to get rid of both of those numbers individually. To get rid of a times 3, we're going to divide by 3. And to get rid of a minus 19, we're going to add 19. But the question is, which one do we do first, and why do we do it first? And the answer lies in the order of operations. You may recall that the order of operations, which is normally referred to as PEMDAS, is just a gimmick for the order in which you do a math problem. P stands for parentheses. E stands for exponents. MD stands for multiplication / division, done left to right. And then AS stands for addition / subtraction, also done from left to right. And this is the order that you would do a math problem if it were just numbers. For example, if the x were a number on the left, let's just focus on the expression 3x minus 19. If we had a value for x, and we put it into 3x minus 19. For example, let's just say x was 10. I just pulled 10 out of nowhere. And if I asked you to work out 3 times 10 minus 19, the order of operations would dictate the correct order. There are parentheses, but the number inside there's just one number inside, so there's nothing inside the parentheses to do. There are no exponents, but there is a multiplication. So our first move would be to multiply 3 times 10, which is 30. We haven't done the minus 19 yet, so it's still there. And then according to the order of operations, the next move, which is the last move, would be to do 30 minus 19, which is 11. Now we want this to equal 32, so we got 11, which means 10 is not the solution. But my point is, when you are evaluating an expression, you do it in the order according to the order of operations. But we're trying to undo an expression. In other words, something got multiplied by 3. And then 19 was subtracted after that, and the result is 32. When you're solving an equation, you are unraveling an expression that already occurred in a certain order according to the order of operations. In this particular problem, the order was multiply and then subtract. So when you're solving an equation, you're essentially undoing the order of operations. And when you undo it, you have to undo it in the reverse order. So what does that mean here? Well, if I were doing the expression 3x minus 19, once you give me a number for x, I would multiply first and then subtract second. So when I'm undoing it, I'm going to undo the subtraction first and then undo the multiplication second. So we're going to start solving this equation by adding 19 to both sides first. We add 19 to both sides. The result is the 19s cancel. Remember, technically they turn into a +0, and that gets absorbed into the 3x, but essentially they just cancel. And on the right side, we get 32 plus 19, which I believe is 51. And now we're down to a single step equation. Get rid of the times 3 with the divide by 3. The 3's quote unquote cancel. They actually divide to make the number 1, which times x is itself. And on the right side, we get 51 over 3. Your first thing for that fraction is to try to do it. And if it doesn't come out to be a whole number, then try to reduce it. 51 is actually divisible by 3. 51 divided by 3 is exactly 17. And if you wanted to, you could check the answer by substituting the 17 back in for the x, and then do the order of operations. 3 times 17 is 51. 51 minus 19 does end up giving you 32. So when you're doing a multi-step linear equation, and you're not sure what step to do first to solve it, ask yourself, how would I work this problem if I knew what x equals, and then begin working it in reverse, or unworking it, I should say, in reverse. Let's take a look at another example. And I'm going to pause real quick because I've got a student texting me. Be right back. All right, for our next example, we're going to solve x plus 4 over 5 equals negative 11. And I know people tend to freak out when fractions show up, but remember, a fraction is just a division problem. Speaking of which, there are two reasons the x is not by itself. Reason number one is there is a plus 4 attached to it. So at some point, I'm going to have to do a minus 4 to counteract that or to undo it. And secondly, there is a divided by 5. So at some point, I'm going to have to multiply by 5 to undo that. But the question is, which one do we do first, the times 5 or the minus 4? You can answer that by asking yourself, what would happen if I took this expression, the entire thing, the x plus 4 over 5, and I actually stuck a number in for the x and worked it out? Well, if I did that, like for example, let's just say you stick in, let's just pick a random number. Let's say you put in 22. If I put 22 in for the x, what do we do first? Do we do the plus 4 divided by 5? Now, I know the order of operations says to do the division first, but there's an implied parentheses when you see fractions. Anytime you see a fraction and either side is more than a single number, there's an implied parentheses around that side. So actually, the order of operations would say we would go inside those parentheses first, do the addition, and then do the plus 5. So if we were doing this problem, we would add the top, and then we would divide. Now, 26 doesn't divide by evenly, but it does give you 5.2. But the important thing is the order we would do that expression in is add the 4 and then divide by 5. When you're solving an equation, you're essentially undoing what was done. In other words, somebody already added 4 and then divided by 5, and the answer they got was a negative 11. When you're solving a basic linear equation or a simple linear equation, you can think of undoing what was already done. So in a nutshell, we're going to multiply both sides by 5 first. All right, let's rewrite the equation down here because I always like to keep the original equation intact. And let's do the move that will get rid of the divided by 5. And to get rid of a divided by 5, we're going to multiply both sides by 5. The net result on the left is the 5's cancel. That leaves the x plus 4. On the right side, we get a negative 11 times 5, which is negative 55. And now we simply have to undo the plus 4 with the minus 4. That will cancel the plus 4 on the left, leaving the x. That's our goal. And on the right side, we have negative 55 minus 4, and that's negative 59. Because if I owe you $55 and then I owe you 4 more, now I owe you a total of $59. All right, so for a lot of these multi-step equations, it's usually pretty straightforward on the correct order in which to get rid of the numbers attached to the x. A good rule of thumb, however, is the further away from the x the number is, the sooner you get rid of it. Going back to the previous example, this 19 was literally further away from the x than the 3, so it was the first number to go. And in this current one, this 5 is kind of further away from the x than the 4 because of the big fraction bar. We'll take a look at a couple more examples and then we'll wrap up this video. We're going to solve 5 minus 3x equals 17. I invite you to pause the video and try to solve it on your own. But first, think to yourself, what's done to the x and how am I going to get rid of the numbers attached to it? I will admit this one has a little bit of a twist because the x is on the right side of the subtraction sign, but I invite you to pause the video and give it a try. All right, if you didn't pause the video and try it, then shame on you. You're about to squander an opportunity to practice without just following my lead. All right, so let's think about what we should do first to solve this equation. What is done to the x? Well, it's multiplied by 3, and then that result is subtracted from 5. In other words, if I was doing the order of operations this 3 times whatever would happen first, followed by that subtraction problem, which means if I undo this, I'm undoing it in reverse order, I have to deal with the subtraction problem first. Should we get rid of the 5 or the 3? Well, using the rule of thumb, we're going to get rid of the 5 first because it's further away from the x than the 3 is. But the question is, what are we going to do to get rid of it? This is a subtraction problem. And so you might think that, well, I have to do the opposite, so I'm going to do an add. But if I'm going to get rid of the 5, focus on the 5 just by itself for a second. That 5 is positive. It is embedded in a subtraction problem. However, subtraction problems are really just addition problems in disguise. You probably know that when you have something like 8 minus -4, that's the same as 8 plus +4. Or when you have something like 8 plus -3, that's the same as 8 minus 3. Basically, anytime you see back-to-back pluses and minuses, like plus minus there, or let's take this one back to where it was. Hold on. It was 8 minus -4. Anytime you have back-to-back signs, whether they're pluses and additions or subtractions or positives and negatives, anytime you have them back-to-back, you can almost think of it as a multiplication scenario. Over here, we have minus and negative. Negative times negative is positive, so it becomes 8 plus 4. And in the second one, we have 8 plus -3, but positive times negative is negative, so that's the same as 8 minus 3. Anytime you see back-and-back pluses or minuses, you can think of it as multiplying in them and using the multiplication rules for positives and negatives. But what does that mean in this problem that we're currently doing? Well, it says 5 minus 3x, but we can reverse engineer it so that it would say 5 plus -3x. Now, is it necessary to do this move? Not really. Let me write that a little bit larger because it is kind of crowded in there. We could rewrite 5 minus 3x equals 17 as 5 plus -3x. That's all subtraction really is, the adding of the opposite. But the reason I wanted to do that is to point out that that 5 is actually part of an addition problem. And to get rid of the 5, we have to combine it with its opposite. Now, could you think to combine it with its opposite by leaving the equation as 5 minus 3x equals 17? Yes, but some people have a little bit of an issue saying, well, I'm going to get rid of this 5 with the -5 because what their brain is thinking is, this is a subtraction problem. Isn't the opposite of subtracting adding? Well, yes, the opposite of subtracting is adding, but who's negative in this problem, the 5 or the 3? The 3 is negative. The 5 is not. The 5 is positive. Since this is an addition subtraction issue and the 5 is positive, we're going to cancel it with the -5 and we're going to subtract 5 from both sides. It's a little tricky when you have what I refer to as a backward subtraction problem, where the x is on the right side of the subtraction sign. 5's cancel. We get -3x on the left because the 3 is still there and it's still negative. And 17 minus 5 is 12. And now the last move is to divide both sides. Now be careful. I know it's a -3 and the opposite of negative is positive. But when it comes to multiplying and dividing, you're setting up a problem that is equal to 1. If I just divide both sides by 3, -3 divided by 3 is not 1. That's -1. When it comes to multiplying and dividing in an effort to cancel, they have to match exactly, including their signs, because -3 divided by -3 would give us 1. 1 times x is x, and 12 divided by -3 is -4. So be careful when you have a backward subtraction problem, because you have to think about, how do I get rid of this number in terms of adding and subtracting, and is the number I'm getting rid of positive or negative? All right, we'll take a look at one more real quick. Yeah, I went there. Solve 1/2 x plus 3/2 equals 7/4. The fact that this has fractions changes nothing in terms of our approach. We still have to get rid of the numbers doing the correct moves. It's just that when we pull off those moves, we have to be a little bit more careful because we're dealing with fractions. If the fractions are bothering you, in the next video, I'll show you a way to deal with them first. But if you wanted to treat this just like the previous problem, then focus on the 2 reasons why the x is not by itself. The x is not by itself because it has 2 numbers attached to it. It has a 1/2 multiplied in front of it and a 3/2 added to it. By now, you probably know that we're going to get rid of the 3/2 first And you probably know that we're going to get rid of it by subtracting 3/2 from both sides. The net result of subtracting 3/2 on the left is it cancels the positive 3/2, leaving a 1/2 x. Excuse me. But on the right side, and let me move my picture here. On the right side, we have to subtract 7/4 minus 3/2, and that's going to require getting common denominators. If you need some help with the rules for doing arithmetic with fractions, let me know, and I'll set up a video for you. But I'm going to assume that we all remember that to add or subtract fractions, we need a common denominator. Our denominators are currently 4 and 2. What is the least common denominator for 4 and 2? Well, the least common denominator is 4. I can turn both of these fractions into something over 4. The one on top is already over 4, so I don't have to mess with it. But how would I turn the red fraction, the negative 3/2, into something over 4? Hint, the only thing you're allowed to do to change the look of a fraction is either multiply both sides by a number or divide both sides by a number. In this case, we're going to multiply both sides of the fraction by 2, because that will give us 2 times 2 on the bottom, which is 4. On the top, we get negative 3 times 2, which is negative 6. And now we can combine these fractions because we have a common denominator. The rule for adding or subtracting fractions is get the common denominator and then do the arithmetic on the numerators, keeping the common denominator. In this case, we have 7/4 minus 6/4, and 7/4 minus 6/4 is 1/4. And now we have 1/2 times x is equal to 1/4. So how are we going to get the x by itself? Well, if you just looked at the left half as a multiplication problem, 1/2 times x, then you would probably say, well, I'll divide both sides by that number because these fractions would cancel on the right side, excuse me, on the left side. But on the right side, we have 1/4 over 1/2. That's a mess, but it's a mess we can get out of if you remember 2 things. Give me a second to rewrite where we currently are. X equals 1/4 over 1/2. Thing number 1 is to remember that every fraction is a division problem, including that giant fraction bar right there, which means that we can rewrite this complex fraction as 1/4 divided by 1/2, because that's all fractions are. Again, this fraction bar right here in the middle became this division because every fraction is a division problem. The other thing you would have to remember is the rule for dividing fractions. The rule for dividing fractions is to keep the first fraction the same, change it from division to multiplication, and then take the reciprocal of the second fraction, turn it upside down. The reciprocal of 1 over 2 is 2 over 1. Well, that was disappointing. For some reason, I lost connectivity and it kicked me out of Zoom and everything on the whiteboard was gone. So assuming that this is still recording, I'm going to pick up where I just left off. We were doing 1/4 over 1/2, looking at it as a division problem, 1/4 divided by 1/2. The rule for dividing fractions is keep the first fraction, change it to multiplication, take the reciprocal of the second. And now to multiply 2 fractions, it's the only thing that is intuitively correct about fraction arithmetic. You multiply the top numbers, you multiply the bottom numbers. Across the top, 1 times 2 is 2. Across the bottom, 4 times 1 is 4. That fraction reduces to 1/2, and we get our solution. All right, I'm going to go ahead and stop this video. And in the next one, we're going to take a look at a different situation where we have x's on both sides of the equation.